Welcome to part 35 of our series on building a Zelda-like game in Phaser 3. In this video, we'll implement locked doors that require keys to open and add a system for respawning objects, ensuring important items reappear when needed. If you're new here, this is part of a full series where we create a Zelda-inspired game from scratch. Check out the playlist link in the description to start from the beginning. Alright, let's dive in and add locked doors and respawning objects. Now that we've connected our inventory manager to our chest game object, we'll want to do the same thing for our doors. So for our locked doors, when our player collides with either our boss door or one of our small locked doors, we'll want to check our inventory manager if our player has the appropriate key. And if our player has one of our small keys, we'll unlock our small door, and if they have the boss key, we'll unlock the boss door. To add in this logic, we're going to add in a new collider, so when our player collides with our locked door group, we'll do that check. To start adding our code, let's jump over to our game scene. Let's go to our register colliders method. And after our logic, where we check for our overlap between our player and our switch group, we'll add in this check. So let's do this, we'll do our physics, let's do add, we'll do a collider, and we'll reference our player, let's do our locked door group, and now we'll have, for our arguments and our callback, we'll have our player, and we'll have the game object that is our door. And in our callback, we'll need to take our game object our player collided with, and we'll need to use that to find our door instance and our objects by room ID from our door map. So currently when our player collides with our door game object, that's not an instance of our door. Instead, this is a separate game object that our player can collide with. When we created that game object in our door class, one of the things we did is we used the set name property to set the name on our door to the ID of our actual door instance. So we'll need to take that ID and use that to do our lookup. So now back in our game scene, first we'll do const, let's do our door object. We're going to set this to our type that we're expecting, and so we'll do our game object, and we'll do as, our phaser, our types, our physics, our arcade, and now we'll do our game object with body. And now that we've typed our door object, we can grab a reference to our door. So we'll do const door, we're going to set that equal to this, our objects by room ID, we're going to do our current room ID. Now we want to do our door map, and now we can pass in our door object, and we'll use our name property, and now we'll do as door. Now that we have our door instance, we can check our type on our door, and if it's not one of our locked door types, then we can return early. So we'll do if our door type, does not equal our door type of lock, and our door type doesn't equal our boss door. Then we want to return early from our collision check. Otherwise, we'll need to check our area inventory to see if we have the appropriate key. So let's do const, we'll do our area inventory. We're going to set that equal to our inventory manager. Let's do our instance, and we want to do get area inventory. We'll pass in our level data, and we'll do our level. So now we'll check our door type, and so if our door type is equal to our lock type, now we want to make sure we actually have a small key, and if we do have a small key, we'll want to use it and then open our door. So now we'll just do if our area inventory, if our keys is greater than 0. Now we want to use our key, so we'll go into our inventory manager, we'll do our instance, let's do use area small key. We want to pass in our level, so we update the right data. And now we'll do our door, and we'll call open to open up our door. And then we can return early from our check. If our door type is not our lock type, then it must be our boss door, and so we'll want to check to see if we have our boss key, and if we don't have our boss key, we can return early. So we'll do if not our area inventory, our boss key. If we don't have that, we'll return. Otherwise, we'll call our door, and we'll call our open method. Alright, so if we save our changes, we should be able to test our code. Let's come up to our boss door. We just want to make sure when we overlap with it, we don't actually open our door. Now if we go over one room, let's try colliding with our locked door, and we'll see our door doesn't open. Now let's spawn our chest, and let's collect our small key from our chest. So now if we come over to our small locked door, we'll see now it opens up without any issues. Nice. So now we'll want to do the same thing with our boss key. So if we jump over to our inventory manager, let's update our default value for our boss key. We're going to set this to be true. Now if we come back to our dungeon, let's go up to our boss door. If we collide with it, our boss door now unlocks. Nice. So now we verified our changes, let's revert our change for our boss key in our inventory manager, and let's save. Now that we've wrapped up our inventory manager and we've connected this to our game, our next feature we'll focus on for our dungeon mechanics is being able to respawn certain game objects in our dungeon and then being able to dynamically show or hide our game objects. So currently in our level, when our player breaks one of our pot game objects, we want to be able to respawn that game object when our player re-enters our room. This is different than like if we defeat an enemy in a different room, we want that enemy to stay defeated until we leave our dungeon or if our player dies. Besides this, one other change we'll do is we're going to add in logic to dynamically show and hide our game objects when our player enters and leaves a room. By default, when we create our level, we're dynamically creating all of our enemies and our game objects and we're populating our phaser world. Even though we can only see this room of our level, we have our other objects visible and we have our physics running for our enemies. Instead of having those run in the background when our player's not in that room, we're going to make those game objects inactive, and then only when our player goes to enter that room will we reactivate them. This will help improve the performance for our game as we make our levels larger. To get started with our changes, first we're going to go to all of our various game objects, and we're going to disable them by default. To start with our changes, we'll start with our game objects. So let's open up our pot class. If we go down to the bottom of our constructor, after we add in our components, let's disable our game object by default. So we'll do this, we'll do disable object. And now we'll want to make this same change to all of our other game objects. So I'm just going to copy this line of code. We'll go into our door class. Let's add in our code there. Let's go into our chest class. We'll make sure the same thing's there. Go into our button class. We'll re-enable our disable object. And now we'll want to do the same thing to our character game objects. So let's go into our character game object class. We'll go up to our constructor where we have our general configuration. And now we're just going to do a check. If we're not the player, then we'll disable our game object. So we'll do if not this is player. Then we'll do this. We'll do disable object. Finally, one last change will be in our spider class. In our constructor, we're currently creating a time event and we're using that to trigger when our spider should start moving. Instead, we'll only want to trigger this timer once our game object is enabled. And so to make that change, we're just going to move this to our enable object method on our spider class. So to do that, we're going to override our method. So let's do public. We're going to do enable object. First, we'll do super, and now we'll do enable object. So we can run our logic on our parent class. Now let's copy this logic here, and then we'll paste it below our enable object. And then one last change we'll do is down in our method for change direction, we're going to have a check to make sure our game object is actually active. So we're going to do if not this. If our game object's not active, then we want to return early. So what we're doing here is by default, when our spider spawns, we trigger our time event to start having our spider start moving right away. Instead, we want our game object to be disabled and so not doing anything until our player enters our room. Once our player enters our room, that's going to trigger our enable object method, which will make our game object visible and active in our scene. Once our game object is active, and that's going to trigger our time event just like it did before. And so once we call change direction, and so we added the safeguard here, so then that way if our player left our room before our delayed call was invoked, now we'll terminate early and not trigger another time event, and then when our player comes back into our room, we'll rely on our enable object method to trigger our new callback. We'll rely on our enable object method to trigger our new time event. Alright, so if we save our changes, if we come over to our browser, we should see right away that our game objects are no longer visible in our scene. So in our first room, we no longer see our locked door game object or our pots for our player to interact with. And if we try moving to one of our other rooms, because we disabled all of our game objects, we're no longer able to do our transition. So now in our game scene, we'll want to add in logic so when our player enters into one of our rooms, we'll want to re-enable those game objects so we'll be able to interact with them. So to add in that logic, let's go to our game scene. We'll come down to the bottom of our class and we're going to add in two methods. We're going to add in a method to allow us to show all of our game objects by a room ID, and we'll add in a method to hide all of our game objects in a room by its room ID. So go to the bottom of our class. For our first method, we'll do show objects in room by ID. For our argument, we'll need our room ID, so this will be a number. We won't return anything from our method. Now I'm going to copy this, and we'll make another method, and now this will just be hide objects in room by ID. So now in our method, we'll just want to loop through our array of each of our game objects, and then call our enable object on that method. So we'll start with our show objects in room by ID. We'll do this, we'll do our objects by room ID. We'll use our room ID we passed in. So we'll start with our doors, and now we'll do for each. And so for each of our doors, we just want to call door, and we're going to call enable object. Let's copy this line of code. And now we'll do our switches and our pots and our chest. And so we'll have our switches. Now for our object, we're just going to call this our button. We'll do our button enable object. Now we'll do our pots. And so we'll have our pot game object. We'll do pot enable object. And now we want to do our chest. So we'll have our chest game object. And we'll do chest enable object. And so now we'll want to do the same thing for our enemies in our room. And so first we're going to check to make sure we actually have an enemy group for our room. So we'll do if this, our objects by room ID, our room ID we passed in. We'll do our enemy group. If it's undefined, then we can return early. If it's undefined, we'll return early. If it's not undefined, now we want to iterate through our children and then enable those objects. So we'll do for, we'll do const child of this, our objects by room ID. We'll do our room ID. We'll reference our enemy group, and now we'll do get children. So now inside our loop, we'll just do our child. We'll do as our character game object, and then we'll do enable object. So now for our hide objects in room by ID, we just want to do the inverse of this, where we just disable our objects. So let's copy all of our logic here. We'll come down here. Let's paste it. Now let's do disable object. Let's copy that, and we'll just update our references. And that's save. Now we just need to update our game scene to use our new methods. We'll start off when our player spawns into our level. We'll want to show our game objects for our room our player is going to spawn in. So let's go up to our create method. Before we call setup player, we'll do this. We'll do show objects in room by ID. Reference this. We'll do our level data. And now we want to do our room ID our player is currently in. Now if we save, we should see when our player spawns, our door object is back in place, and we can see our pot game objects. Now we'll want to do the same thing when our player goes to transition to a new room. We'll want to despawn our current game objects and then spawn our game objects in our other room. So if we go to our handle room transition method, so in our method, before we start our transition, we'll want to show our game objects in our next room. That way they'll be ready by the time our player transitions into that room. And after our player completes our transition, we'll hide our objects from our previous room. So after we disable our door game object, we'll do this. We'll do show objects in room by ID. We'll do our target door, and we'll grab our room ID of that where that door is located. So now we'll come down to where we complete our transition. And after we re-enable our door game object, now we'll disable our game objects in our previous room. So we'll do this. We'll do our hide objects in room by ID. We want to use our original door, and we want to do the room ID of that door. Alright, so now if we save, we should be able to test. If we have our player go into our next room, we should see that our enemy game objects are spawned and our doors are spawned. So now our player is blocked when they try to leave. If we open up our door and go back through it, we should see that our game objects are still present in our previous room. Alright, finally for our last change, now we just want to add in logic so we can respawn our pot game objects after we break them. So in our game, if we pick up one of our pot game objects and we break it, and we transition to our next room, when we respawn and show our game objects in that room, if we come back to our previous room, we'll see that our pot game object has now respawned in the position of where it broke at, instead of being respawned at its original location. To fix that, we're going to add a new method to our pot class that will allow us to reset our x and y value for our game object. So at the bottom of our class, let's make a new method. We'll do public, we'll do reset position. For our method, we won't return anything. And then all we'll want to do in this method is we just want to update our game object's position, and then we want to re-enable our game object. We'll do this, we'll do set position. Now we're going to reference our stored position that we have in our game object. So we'll do this.position.x, and then this.position.y. And now we'll just call enable object to re-enable our game object. And now back in our game scene, let's come down to our logic for our show and hiding our game objects in our room. And for our pot, instead of calling enable object, we're just going to call reset position. Alright, so if we save, we should be able to test our changes. Let's grab our pot game object. If we break it, let's go into our next room. Let's go ahead and come back to our previous room. Now when we enter our room, our pot respawns, but it starts breaking right away. And to fix our issue, we'll need to update our origin and our game object. So when our player picks up our game object, we update its origin so we can position our game object above our head. So we're just going to call set origin. And now we want to reset it back to what we had previously. And so we'll do 0 for our X and 1 for our Y. Alright, so if we save, let's grab our game object, let's break it. We'll move over to our next room. Let's reopen our door. If we go back into our room, we should see now our game object respawns, but it's not in the right location. So what's happening here is when we go to spawn our game object, since our two physics bodies are touching, we have our collider. This is updating our positioning on our game object when we try to position it in our scene. To avoid this, we could either update our physics body and our game object to be a little bit smaller, or space our objects further apart, or we can just add in a small delay when we go to spawn our game object, which will allow us to avoid our collision check until our next update of our physics loop. By doing this, it'll allow us to get our game object respawned in the original location. To end that change, we just do this, we'll do our scene, let's do time, we'll do a delete call, we'll do 1 millisecond, and now inside our callback, this is where we'll do our logic. So we'll grab these lines of code, let's paste it in here, we'll save. Now if we grab our game object, let's break it. We'll go into our next room, go back to our room. Now our game object should respawn. We no longer have our collision, and so it goes back in its original location. Nice. Alright, so one last change we'll do for our code is currently we have a bug where if our player is carrying one of our game objects, if they try to go to our next room in our dungeon, what happens is our game object starts colliding with our boundary around our room. Our player stays in our state where we're carrying our item. To fix this, once we start a transition to go to our next room, we'll want to drop our item our player's carrying and transition our player back to our idle state. So to add in this change, let's go into our idle state. After we reset our player's velocity, we'll check to see if our player is currently holding an item, and if they are, we'll go ahead and drop that item. And so this will be the same logic we do in our hurt state, so let's jump over there. Let's grab our block of code where we check to see if we're carrying our item. We'll come back to our idle state. Let's paste in our code. Let's update our imports. And so now after we reset our velocity, we'll see if we're carrying an object, and if we are, then we'll drop it. So now we just need to update our logic in our game scene to transition our player to our idle state to trigger this logic. And so to do that, we'll need to be able to get a reference to our state machine for our player. To do that, we'll come into our game object class. Let's add in a new getter to allow us to retrieve our state machine. So we'll do get state machine. We'll return our state machine instance. So we'll do return this, our state machine. Now if we come to our game scene, let's go to our handle room transition method. And then after our checks where we disable our game objects, now we'll want to set our state to our idle state. So we'll do this, we'll do our player, let's do our state machine, let's do set state, and we'll do our character states. Now we'll do idle. Alright, so if we save, we should be able to test our changes. So if we pick up our pot game object, if we try to go to our next room, we'll see right away we drop our game object and break it, and when our player enters our next room, they're now in the right state. That's it for this part of the series. If you found this helpful, be sure to hit the like button. It really helps out the channel. And if you're following along, make sure to subscribe and turn on notifications so you don't miss the next video. If you have any questions or want to share your progress, drop a comment below. I'd love to hear from you. Alright, thanks for watching and I'll see you in the next one.